So where we are using this LPP, so we are using in marketing management and to reduce the complexity of to decision making. So operation research is a systematic way to decision making. You have to prove that traveling salesman problem as an assignment problem. So all the steps are management applications of or some areas of applications are we are using this in finance, budgeting, coefficient of each variable. X1 coefficient is 1, X2 coefficient is 1. Hello everyone, I am Shweta, Computer Science faculty, Vidhyaashram First Grade College, MYSURU. So your exams are coming. Now today I will explain the model question paper on operation research. So please follow this question paper pattern and important questions. So you can expect so many questions, important questions on this model paper also sometimes. So please follow the question paper pattern which I am explaining today. Let's get started now. So this is your 80 marks theory paper and you can expect 2 marks, 10 questions. So you can score 2 into 10, 20 marks in part A, and in part B you can score 60 marks. You have to attend 4 questions. For every questions you will get 1 options. In each unit you will get 2 questions. So you can score 60 marks in the second part, that is part B. So each question carries 15 marks, 15 into 4, 60 marks. So totally it is 80 marks theory paper. Clear? And first part A is 2 marks questions. So first question, define operation research. So what is the definition of operation research? So operation research is a quantitative approach, is a systematic way to decision making. So operation research is a systematic way to decision making and based on the scientific method of problem solving. With the help of this operation research technique, we can solve the complex situation and the complex problems. Is it clear? So operation research is a systematic way for decision making. And the next one, so what is modeling? Modeling is means of providing a structural framework. Is it called a clear structural framework to the problem for purpose of understanding and dealing with reality. So this modeling means it's a clear structure of framework. Clear? The technique is called as modeling. And the next one is define basic feasible solution and unbounded solution. So what is this basic feasible solution? It is called as BFS, basic feasible solution. 2 marks question. A basic feasible solution is called a solution if all basic variables are greater than or equal to 0. So I hope you have cleared about the simplex method LPP problems, right? So when you are constructing the LP model, first you are writing the objective function and subject to constraint and non-negativity constraint. Is it right? So all the non-negativity constraints should be greater than or equal to 0. That is called as basic feasible solution. And what is this unbounded solution? So if the value of the objective function can be increased or decreased indefinitely, then the solution is called an unbounded solution. When you are plotting the graph, you will get no feasible solution, right? That is called as unbounded solution. And the next question is, what is linear programming? Very, very important question for 2 marks. What is LPP or linear programming problem? So LPP, it deals with the optimization. Optimization in the sense maximization or minimization. Clear? Optimization means maximization and minimization, that is called as objective functions, right? And of a function of variables known as objective function subject to a set of constraints and linear equations and inequalities are called as constraints, that is subject to constraints. So LPP means It's a combination of optimization, that is maximization, and minimization, and variables, that is subject to constraints in the form of equations. That is called as linear programming problem. Is it clear? And the next one is, what are different methods of solving LPP? Linear programming problem can be solved by different method, that is graphically. So we can solve this LPP by graphical method and simplex method, big M method, and two-phase method. I hope you have cleared about this graphical method to draw a graph by using LPP construction, and we can solve this by simplex method and big M method and two-phase method. Very important question for 2 marks. And the next question is question number 6. What are the advantages of duality? So in duality, we are interchanging the objective function, coefficients of objective function to RHS of constraints value, right? So computational procedures can be considerably reduced by converting into dual if the primal problem contains a large number of rows. Example, in primal problems, if you get a large number of rows, that is x1 plus 2x2 plus 3x3 less than or equal to 7, 3x1 plus 5x2 plus 11x3 less than or equal to 15, and 5x1 6x2 plus 9x3 less than or equal to 2. So if you get large number of constraints, that is rows, so we can convert this into columns. This is in the form of primal. We have to convert this into duality. So here, with the help of this duality, we can reduce the equation. Clear? So large number of rows, that is constraints, and a smaller number of columns, that is variables. Clear? We can interchange the rows and columns in duality. And solution of the dual checks the accuracy of the primal solution for computational errors. So here, with the help of this duality, we can reduce the equation and it can check the computational errors. This is the duality advantages. And the next one is define transportation problem. So very important and easiest concept is transportation problem. So what we are doing in transportation problem? So we are finding the total minimum cost in this concept. Is it right? So transportation cost is reduced with the help of 3 concepts, that is northwest corner, least cost, and Vogel's approximation method. What is the definition of transportation problem? It is special kind of LPP in which goods are transported from a set of source to set of destination. So in transportation problem, they will give you the source and destination. So we have to find the set of goods from source to destination, and subject to that supply and demand. So we'll get the supply and demand value of the source and destination respectively, such that the total cost of transportation is minimized in transportation problem. So this is a special kind of LPP. Clear? So in transportation problem, we are finding the total minimum cost in transportation problem. And the next one is mention the different methods used in finding initial basic feasible solution to transportation problem. So an initial basic feasible solution, we are finding the total minimum cost with the help of these 3 methods, that is northwest corner, least cost method, Vogel's approximation method. So definitely there will be a problem on this concept, northwest corner, least cost, or Vogel's approximation. You can expect any one problem and any one computational procedure on this concept. So you can score 15 marks on this concept. And the next one is, what is an assignment problem? In assignment problem, we are assigning the right job to the right operator, right? And an assignment problem is a special case of transportation problem where the objective is to assign each source exclusively to each destination. Clear? For every source and destination we are allotting, we are assigning the right job to the operator. In other words, assignment problems involve matching of every origin with one particular end point so as to minimize cost or to maximize profits. In assignment problem, we are maximizing the profits and minimizing the loss. Is it clear? We are assigning the right operator. So this is called an assignment problem. And the last question in part A is, what is game theory? Very important question for 2 marks. Game theory is a study of mathematical models of strategic interaction. So game theory means it's a strategy. So it's a strategic interaction among rational decision makers. It has applications in all fields of social science as well as in logic systems science and computer science. So graph theory is a special kind of mathematical logic. Keep in mind, is a special kind of mathematical models of strategic interaction. Is it clear? This is 2 marks question. So this is about your part A. In part A, you will get 12 questions. So you can attend any 10 questions in part A. You can score 20 marks. And the next question is, define minimax maximum principle. So in every unit, you can expect 3 questions. 3 questions in the sense, in the first unit, you will get 3 2 marks question. And in second unit, 3 2 marks question. And third unit, 3 questions. Fourth unit, 3 questions. So 12 into, so 3 into 4. So in every unit, you can expect 3 questions. So totally you have 4 units. 3 into 4 is 12 questions. Clear? So in every unit, you have to write. In every unit, you can expect 3 2 marks question. Okay, you can attend any 10 questions. So in game theory, so first question is, what is game theory? And the second question is, define minimax and maximum principle. So what is this minimax and maximum principle? As the name suggests, is a method in decision theory for minimizing the maximum loss. So in game theory, we are minimizing the maximum loss and maximizing the profit. Clear? And it can be thought of as a maximizing the minimum gain, which is also known as maximin. So minimax in the sense minimizing the maximum loss. So maximin means maximizing the minimum gain. This is a concept of minimax and maximin principle. And the last question is, in game theory, define critical path. So you can expect what is PERT, expansion of PERT, and what is the meaning of PERT also you can expect. So define critical path. Critical path is CPM, is a step-by-step project management technique. So in network analysis, we have studied this concept in network analysis. So CPM and PERT concept. So what is this CPM and PERT concept? It is a project management technique for process planning that defines critical and non-critical tasks with the goal of preventing time frame problems. With the help of this critical path, we can analyze the critical path from source to destination. So in network analysis, we are studying this concept called critical path. So this is about your part A, 12 questions. You have to attend only 10 questions. You have 2 questions choice. And coming to the next part called part B. So each question carries 15 marks. So 15 marks can be partitioned into 7 marks and 8 marks, or 8 marks into 7 marks, or 7 marks, 4 marks and 4 mark also. So totally it's 15 marks question. Part B, first question is, that is 13A1 and 13A2. You have to attend 13A1, A2 or 13B1, B2. You have one choice in part B. So each question carries 15 marks. So this first question, explain the application of management where tools and technique of operation research is applied. That is for 7 marks. So first question is A1, this question carries 7 marks. So next question is 8 marks. So this is A1 question. So what are the application of management where the tools and technique of operation research is applied? So you have to list, you have to write the complete answer for 7 marks. So here I have included the key points. Management applications of OR, some areas of applications are we are using this in finance, budgeting and investment, cash flow analysis, investment portfolios and credit policies, account procedures in budget and finance. And coming to the purchasing, procurement and exploration and rules for buying, supplies and replacement policies, quantities and timing of purchase. In this kinds of technique, we are using the operation research for management. And production management is very important concept. Physical distribution, facilities planning, manufacturing and maintenance and project scheduling. And the last one is marketing. So in marketing management, we are applying this operation research. So product selection, timing is a points in marketing. Is it clear? This is for 7 marks. So you have to explain all this. So next one is second question, that is 13A2. Explain the principles of modeling. So you can expect this question for 7 marks. Very important question. Applications of OR, some management technique. And the next one is principles of modeling. So you can observe this question. You got this question for 2 marks also. What is modeling? And here it is for 8 marks. Principles of modeling. So you can write this completely. So do not build up a complicated model when simple one will suffice. And beware of modeling the problem to fit the technique. And the deduction phase of modeling must be conducted rigorously. And models should be validated prior to implementation. And a model should never be taken too literally. So these are the very important points for principles of modeling. So already have discussed all this concept in my YouTube session, previous session. Those who have not seen, please follow the link below and please watch all the session and you can practice thoroughly. Next point, so you can write this: model should neither be pressed to do nor criticized for failing to do that for which it was never intended. And beware of overselling a model. And primary benefits of modeling are associated with the process of developing the model. Very important model. And model cannot be any better than the information that goes into it. And models cannot replace decision makers. So these are the very important principles of modeling. And the next one is second question, that is 13B1. Explain the scope of operation research. Very important question. Modeling, scope of OR and applications of OR, advantages, disadvantages and role of operation research in decision making. These are the very important question for 7 marks and 8 marks. This question is for 8 marks. So in agricultural and in finance, in industry, in marketing, in LIC, we are using this operation research. These are the scope of operation research. So you have to explain this. This is just a point have included. So you have to explain everything in agriculture, for which purpose we are using in agriculture, finance, industry, marketing and LIC. And the next one is explain the applications of the linear programming. And the next question is 13B2. 13B1 is for 8 marks, 13B2 is 7 marks. Explain the applications of the linear programming. Very important question. LPP applications. And so where we are using this LPP? So we are using in marketing management, and to reduce the complexity of the resource management, we are using this LPP model. Is it right? And the next question is part B, second question, 14A1 and next is 14A2. So definitely 14A1 is LPP problem. A firm manufactures 2 types of products, that is A and B, and sells them at a profit of rupees 2 on type A and rupees 3 on type B. So how many products are there? Product A and product B. So here you have to please write the table properly, then easily you can construct the LP model. And each product is processed on 2 machines, that is G and H. Type A requires 1 minute of processing time on G and 2 minutes on H. Type B requires 1 minute on G and 1 minute on H. Please list out the given instruction. The machine G is available for not more than 6 hours 40 minutes. So before that you can observe this instruction. All these values are in a minute. That is example 2 minutes and 1 minute. Is it right? But here the machine G is available. So availability for not more than 6 hours 40 minutes. That is for machine G. 6 hours 40 minutes. You have to convert this into minutes. 6 into 1 hour is 60 minutes plus 40 minutes. So 60 into 6 is 360 plus 40, it is 400 minutes. You have to convert this. And next one is, while machine H is available for 10 hours. 10 hours means 10 into 60 minutes. So 600 minutes. So it is 400 minutes and this is 600 minutes. Convert this into minutes. They have given in the form of 6 hours 40 minutes in hours. Convert this into minutes. While machine H is 10 hours during any working day. Formulate the problem as a LPP. This is 7-mark question. You can expect any one question on this concept, that is LPP, by instruction method. So now with the help of this given instructions, we have to construct the LP model. So how to construct the LP model? So try to write the table like this. So how many products are there? Product A and product B. And we have 2 machines, machine G and machine H. And they have given the profit. If a company manufactures and company produces and company create means, so you can write that it is maximization problem. Clear? Company creates, company manufactures and company produces. And they have given sell them at a profit of, they have mentioned that profit of rupees 2 and rupees 3 for type B. Profit means obviously it is maximization problem, right? So max z is equal to 2x plus 3y, that is 2 rupees for machine A and 2 rupees for machine B. This is your profit. Clear? And subject to constraints. So just write the machine G and machine H processing time, that is 1 minute for type A, 1 minute for type B, 2 minutes for type A, 1 minute for type B. That is 1 means x plus y and 2x plus y. And availability, they have given the availability in the form of hours. 6 into 60 minutes plus 40 minutes is equal to 400 minutes. So these processing time are in the form of minutes. Convert this into minute also. So 10 into 60 minutes, this 600 minutes. So now the availability is less than or equal to 400, less than or equal to 600. Is it here? So these are the constraints and objective function. So obviously we have 2 decision variables, x and y should be greater than or equal to 0. Very simple concept. So you can construct the LP model. And the next one is solve the given LPP using graphical method for 8 marks. Very important question. So 14A1 is LPP by instruction method and 14A2 is graphical method. And here they have given the max z is equal to 2x plus 3y. And subject to constraints, we have 3 subject to constraints. And here x1, x2, that is greater than or equal to 0. So now, what is the first step in construction of graph? So take this inequality equation into, convert this into equality. X1 plus 2x2 is equal to 2000. And next one is x1 plus x2 is equal to 1500. So put x1 is equal to 0. x1 is equal to 0 means x2 is equal to 1000. So the first point is 0, 1000. And next put x2 is equal to 0. So x1 is equal to 2000. The final point is, that is 2000, 0. So you got this first point and second point. In first constraint, you got 2 points. And put x1 is equal to 0, x2 is 1500. So point C is 0, 1500. Put x2 is equal to 0, x1 is equal to 1500. So point D is 1500, 0. And you have one more constraint with one constant value, that is x2 is equal to 600. Clear? Now, we can't do anything for this constraint. We can't apply anything. So, x2 is equal to 600. So, now totally we have 5 points. We have to draw a graph now. This is x-axis and this is region 0. This is y-axis. Now, among these points, we have the highest value called 2000. So, I will start from 500, 1000, 1500, 2000, 500, 1000, 1500 and 2000. Is it clear? Now, I'll join the constraint 0, 1000. 0, 1000. This is the first constraint, and 2000, 0. Join these two constraints first. And it is towards the region because it is less than or equal to and less than or equal to. Clear? And the third point is 0, 1500 and 1500, 0. Join these two constraints. And the last point is x2 is equal to 0. So x2 means its y value. So here, this is my x2 value, that is 600. So now I'll join this 600 point. And here I'll join this point because x2 value is not there. So now you can draw the feasible region. Here 3 points are connected each other, that is intersected point. This is an intersected point. Now which is a feasible region have to mark here. So all these constraints are less than or equal to, less than or equal to. So it is maximization problem. So it face towards the region, that is this face, it facing towards the region. If it is greater than or equal to, above the region. So you have to mark this as a feasible region. This is feasible region. Is it clear? Now you got the corner point A, B and C, D. You have 4 corner points. Is it right? So take this corner points 0, 0. B is 0, 600 and C is, it is 600, 1000, 600 and D is 0, 1000. So this corner points value you have to substitute in objective function to get the maximum value. So now substitute the value of x and y. So here x is 0, y is 0. So we will get 0 only for first point. And now 0, 600. So 0, 2 into 0 plus 3 into 600 and we will get 1800. And 1000, 600, 2 into 1000 plus 3 into 600. Substitute the value of x and y for each point, corner points value to this objective function. You will get the maximum value. So it is 2000 plus 1800, that is 3800. I hope this is a maximum value. And the next one, last point is 0, 1000, that is 2 into 0 plus 3 into 1000, that is 3000. So which is a maximum value here? 3800 is the maximum value which comes under 0.1000, 600. So maximization value is equal to, it is 3800, which comes under the point x, 1000 and y, 600. So this is about your graphical method. For this, you can score 8 marks. And the next one is 14th B1. Explain the computational procedure for B.C.A method. Very, very, very important question for 7 marks. You can expect this question. So definitely there will be a problem or computational procedure. Computational procedure means you have to explain the steps how to implement this B.C.A method. So you can expect B.C.A or two-phase method. You can expect any one of this computational procedure for 7 marks or 8 marks. So how to explain this? You have to explain the steps. So if the problem is of minimization, convert this into maximization by multiplying -1 for each objective function. If any of the constraints, if the RHS coefficient is negative, already I have explained these steps. If the RHS coefficient is negative, make it positive by multiplying both sides of the constraints by -1. Example, x1 plus 5x2 less than or equal to -7. So here the RHS value is -7. So all this RHS value should be in a positive in simplex, in B.C.A and two-phase method and in graphical method. If you get the negative value, multiply this each equation by -1 and convert this into positive. That is the second step. And change the inequality sign into constraints, that is less than or equal to greater than or greater than or equal to less than. So the constraints sign will be changing. If the constraints introduce slack, surplus and artificial variables on the LHS to convert the constraints into inequalities. So here in B.C.A method, you are introducing the slack variable, surplus variable and artificial variable. If you get equals in a constraint, you have to add the artificial variable A1, A2, etc. If you get less than or equal to constraint, you have to add slack variable, that is S1, S2, etc. And if you get greater than or equal to, you have to subtract with the slack variable and plus artificial variable, etc. So S2 plus A2, etc. Clear? For less than, slack variable; for greater than, subtract the surplus variable with artificial variable. This is the main constraint. And if the constraint is less than or equal to, add only slack variable on LHS, and greater than or equal to means subtract surplus variable with add artificial variables. If the constraint is equal, add only artificial variable on LHS. Clear? These are the main steps which we have to do it in a B.C.A method. And the next question is 14B2, that is for 8 marks, is simplex problem. So here you have LPP. So solve this by simplex method. Definitely there will be a problem on this simplex method, B.C.A method and two-phase method. One problem and one computational procedure. Clear? So please practice these problems properly. So first step is convert this inequality into equality by adding slack variable. So here it is less than or equal to, less than or equal to. In simplex method, you are not supposed to add the surplus variable and artificial variable. That is only for B.C.A method and two-phase method. So here the first question is, first equation x1 plus x2 plus s1 is equal to 4. So here I am adding the slack variable because it's less than or equal to 4. Convert this inequality into equality by adding slack variable s1, slack variable s2. So now the total decision variables are x1, x2, s1, s2 should be greater than or equal to 0. And now I'll write it in a standard form, the objective function. I have added this S1 and S2. So here you have to add 0 S1, 0 S2. Always the coefficient of this slack variable is 0. And the next one is we have to write the initial simplex table. So first table, this is the first initial table in your simplex method, Cj, coefficient of objective function, and write the coefficient of each variable, that is 3 and 2, 3x1, x1 coefficient is 3, x2 coefficient is 2, s1 coefficient is 0, x2 coefficient is 0. So that you have to write it in a first row. And the second one is coefficient of basic variable and basic variables. So how many basic variables have added here? That is slack variable 1, slack variable 2. That is your basic variable in every problem. The coefficient of basic variable is 0 and 0. And now, how many basic variables are there? S1, x2, S1, S2. You list out all the basic variable with solution. Solution in the sense RHS value, and you have to find the ratio also. So already I have explained this problems. So now here you have to write all the given values, that is coefficient of each variable. x1 coefficient is 1, x2 coefficient is 1, and s1 value is 1, and here x1 is 1, x2 is minus 1, s2 is 1, s1 is 0 in the second equation. Write all the given values, and solution is RHS value. RHS value should be always positive. And next is Zj. So how to calculate this Zj? 0 into 1 plus 0 into 1. In first initial simplex table, all the Zj value is always 0 in every problem. That is in a simplex method. So next is Cj minus Zj. Subtract with 3 minus 0, 2 minus 0, 0 minus 0, 0 minus 0. So you will get this 3, 2, 0, 0. So after this initial simplex table, check whether it's satisfying the optimality condition or not. So here you have positive, positive, 0, 0. For all maximization problem, Cj minus Zj value should be negative or 0. Clear? So here I have positive value with 0. So it's not satisfying the optimality condition. Next we have to convert this into optimality condition. So now here you have to write the key column, and so how to find the key column? You have to choose a maximum value. Maximum is 3. It comes under x1 column. x1 column is key column. And here find the ratio. So 4 by key column 1 and this 1, and 2 by key column 1, this 2. So among this ratio, which is the least value, 2 is the least value, it comes under this row, that is S2 is called as key row. So key row is S2, living variable, that is S2. Key row is called as living variable, and key column is x1. x1 is called as entering variable, and which is a common value for both key row and key column. So 1 is called as key element. This is also called as pivot elements. First you have to list all the living variable, entering variable, and key element. And next is you have to find the iteration, first iteration, and next one is here you have to find the iteration. So now again with the entering variable and leaving variable, you have to find the key row and key column. And next is again you have to check whether it is satisfying the optimality condition or not. So find Zj and Cj minus Zj. So how to find Zj? 0 into 0 plus 3 into 1, 0 into 2, 3 into minus 1. So like that you can find the Zj value, and next is Cj minus Zj. So Cj minus Zj means 3 minus 0, 2 minus 5, 0 minus 0, 0 minus 3. So now it's not satisfying because it has a positive value. And next you have to find again the key column and key row. Is it clear? And next one is again find the second iteration. So definitely in the second iteration you will get the negative value and 0 value. Now it is satisfying the optimality condition. Clear? And the next question is 15th A1. Write the steps of mathematical formulation of transportation problem as LPP. So here you have to write the steps, procedure for finding the transportation problem. This is for 7 marks. So here you have to write the procedure for finding the transportation problem. So in transportation problem, we are finding the supply value and demand value. So what is the first step? So first you have to check whether the given problem has balanced problem or unbalanced. If it is balanced problem, you can proceed, and if it is unbalanced, you have to make it as a balance by adding a dummy row and dummy column. Is it clear? And next is you have to find the balanced problem, and in northwest corner, we are finding the north corner cell, as well as in a least cost method, we are finding the least value. And next, in Ogle's approximation, you have to find the row difference and column difference. So among the row difference and column difference, you have to select the maximum value and you have to select the least cost. And all the unallotted cells and allotted cells you have to check. So you have to take the allotted cells and add all the allotted cells, you will get the final transportation cost. So this is a procedure for finding the transportation problem. And the next one is find the initial basic feasible solution for the following transportation problem using northwest corner method, that is for 8 mark. So here it is northwest corner problem. So in northwest corner method, you have 3 rows and 4 columns. So you have the supply value and demand value. So now check whether it is a balanced problem or unbalanced problem. So 18 plus 9 is 27 plus 7 is 34, and it is also 8 plus 13, 20, 34. So it is a balanced problem. And next one is, so we have to choose a north corner cell. So which is a north corner cell here? So 19 is a north corner cell. It comes under demand value 5 and supply value is 7, which is the least value. 5 is the least value. Allot 5 rupees. And 7 minus 5 is 2 rupees and 0. If you get 0, you can cancel this entire column. And next north corner cell is 30. 2 and 8, least is 2. And you can cancel this. And 8 minus 2 is 6. And next north corner cell is 30. 6 and 9, least is 6. Allot 6 rupees to this cell. 9 minus 6 is 3. And next north corner cell is 40. 3 and 7, least is 3. And 7 minus 3 is 4. And next is 70 and 20. So here 18 and 4, least value is 4. 18 minus 4 is 14. So at the last digit, you will get same supply value and demand value. So 14, allot this 14 rupees. So you can cancel it. So now take all the allotted cell, 5 into 19, 2 into 30, 6 into 30, 3 into 40, 4 into 70 and 14 into 20. You will get 1015 rupees transportation cost. Very simple concept, northwest corner. So among these 3 concepts and least cost method, so definitely one problem will be there and one computational procedure. So you can score 15 marks. Clear? And next one is 15B1. Solve the following assignment problem. Definitely question it is for 8 marks. So here they have given the given assignment problem. So what is the first step? You have to find the row difference and column difference. So here consider the least value. 8 is the least value and subtract with the other value. 8 minus 8, 26 minus 8, 17 minus 8, 11 minus 8. So in the next row, 4 is the least value, subtract with the other value. In the third row, 15 is the least. Fourth row, 10 is the least value. So subtract this value, you will get this row difference. So after this row difference, again you have to take this row difference and find the column difference. So no need to take this for column difference. So after this row difference, by using this table only, you can find the column difference. In the first column, which is the least value, 0 is the least value. If you get 0, again you will get the same value. And second column, 4 is the least value. Third column, 0 is the least value. Here also 0 is the least value. So you'll get this column difference. And here, so after this column difference, we have to find the row scanning. Very important step is row scanning. So now you have to allot zeros to the right operator. So in the first row, if you get 1 0, you just put a square box and vertical line. And in second row, I have 1 0. In third row, 2 zeros. In fourth row, 1 0. And row scanning is done. Next is column scanning. In first row, it's cancelled. Third row, 1 0 and horizontal line. So all the zeros have covered. So now, how many zeros are assigned? 1, 2, 3, 4. 4 zeros assigned. So now, it is a square matrix because number of square marked should be equal to the number of rows and columns. So how many number of rows and columns are there? 4. So it is a square matrix. So after this square matrix, you have to assign the value. So this 0 assigned in A to P. So A to P and B to R, C to Q, D to S. So what is the virginal value for 0? A to P, it is 8 and next is 4 and C to Q is 19 and D to S is 10. So add all this value, 19 plus 10, 29 and 29 plus 4 is 33, 33 plus 8 is 42. So this is your assignment problem. And the next question is state traveling salesman problem and formulate traveling salesman problem as an assignment problem. So assignment problem can be solved by Hungarian method. Just now I solved the Hungarian method. And here you have to write the steps for traveling salesman problem and you have to prove that traveling salesman problem as an assignment problem. So all the steps are as it is which you are doing in an assignment problem. So here you have to write the traveling salesman. You have to follow the traveling salesman rules. So what is the traveling salesman rules? So if the delivery person is starting his way from point A, he has to visit each and every node exactly once and has not visited twice and has to go back to the same point. Is it clear? So you have to write the steps for this. So traveling salesman plans to visit N city. He wishes to visit each city only once and again arriving back to his home city from where he started. That is, you have to mention if there are N cities, then there are N minus 1 possible ways from his tour. And example, if the number of cities to be visited is 4, then there are 3 factorial, that is 6 different combination is possible. So these are the steps you have to explain for traveling salesman problem for computational procedure. And the next one steps is solve the problem as an assignment problem and check for a complete cycle. And next is to start with assign the next least element other than 0 and complete the assignment. Write the optimum assignment schedule and calculate the cost and time. This is about your traveling salesman. And the last part, last question is 16th question, A1, A2 and B1, B2. Explain the general rules for dominance property. So, have explained this dominance property for game theory. So, here we are using the strategy. So, what are the steps you have to use? If the elements of a column say ith column and greater than or equal to the corresponding elements of any other column, say jth column. So, you have to write the ith column and jth column steps, everything. And the next one is you have to explain about pure strategies. Clear? And the next one is, last question is, that is A2, A1, A2, find the minimax value and maximum value of the following games, that is for 8 marks. So here they have mentioned only find the minimax and maximum value. Is it clear? So now we have A1, A2 and A3. So now it is B1, B2 and B3. We have two questions, question number 1 and 2. Find the minimax and maximum principle. So list all the given value. So row minima, row min and col max. You have to find. So which is the least value? 1, 1 and 1. Highest value 6, 3 and 6. So now find the minimax and maximum value. So in row minima, you have to find the maximum value. So maximum is value are same, it is 1 only. Here in column max, you have to find the minimax value. So is this equal? Min max is not equal to maximum. So 1 is not equal to 3. So this is maximum value, minimax value. That's it. And now again row minima and col max. So here -1, -6, -9 is the minimum value. And here 6 and 8 and 0 and next is 4 is the maximum value. So minimax value. In row minima, you have to find the maximum value. Maximum is -1 and minimax value is 0. So is this equal? 0 is not equal to -1. So it has no saddle point and minimax value is 0, maximum value is -1. And the last question is explain the following types of games and saddle point, that is for 7 marks. So we have different types of game, that is zero sum game and non-zero sum game. So zero sum game and non-zero sum game, you have to write the definition for this. Very important question. Zero sum game and non-zero sum game. Also we have one more type of game, that is asymmetric games. And next question is what is saddle point? Saddle point in the game you have to write the maximum value is minimax value, both are same means it has a saddle point. And the next question is 16th B2, write the difference between CPM and PERT. Very important question for 7 marks. So you can list out the comparison between PERT and CPM, project management review technique, and CPM, that is critical path method. And the next one is applications of PERT and CPM. So you have to list the applications for 8 marks. Research and development project, equipment maintenance, setting up of new industries. We are using this PERT and CPM project because it is a project management technique. And construction projects, design of plants and dams and machines, and shifting of manufacturing location to another location. We are applying this PERT and CPM. Control of production in large shops. We are applying this. Marketing, penetration programs, the organization of big programs, conferences, etc. So we are applying this CPM and PERT concept. This is about your question paper pattern and one model question paper I have explained. So all the best for your exams. Please follow the instructions and question paper pattern. Please study all the units. Thank you all. Take care. Bye-bye. See you.